Hello fantastic people, I hope you're doing great. We all know that developers love caves, right? So that's what we'll create today. We'll be generating random caves using the random walk algorithm. So at the end of this tutorial you should have a script that will allow you to easily generate new caves. I hope you're excited. For this tutorial you will need a simple grid system, so you can either follow my tutorial on the grid system, you can find it on my channel obviously, or you can download the ready code from the repository which is linked in that particular video and also under this video in the description. Okay, so let's talk 2 minutes about the algorithm itself. Nothing complex there. First, obviously we start with a grid. On that grid, we draw a border. That is not part of the algorithm yet. It's just for us to have some visual space, right? So here we have 7 cells, and here we have also 7 cells. So that gives us, if I'm counting correctly, 49 cells. Now, before we start, we have to make a decision if we want to include the border cells, like if we want to treat them as valid cells for a cave or not, because in some cases, and for example in the case of our implementation, we'll be discarding those ones in the sense that you won't be able to dig a cave in the corner, in the corner cells, not corner in the border cells, because this would create an opening sometimes, and you know your character could get out using that. Of course, if you sometimes you may want that. For example, you may want a game based on levels where the character can transition from one level to the other. In that case, that could be fine. But in our case, we want like there to be always border around the cave. Now, so we exclude those ones. That means our working zone is effectively here, and that leaves us with grid 5 by 5, which is 25 cells, and that is pretty good number. Obviously, the larger the grid, the crazier the cave can be, and the more interesting things will be happening. Now, what we do, we have to select a number of cells that we want to remove, that we want to dig inside the walls. And it is hard to say what is good number, because it varies a lot depending on size. So basically for small grids like that, I find a number around 50% to be good number, but the larger the cave is, the higher you can be. But you still have to be careful, because I think you would have to experiment, but I think something over 75% of the available cells will be already too much. So I would say the 50% is always kind of safe number to use. So let's assume, so let's say we have here 25 and half of that would be 12 and a half. So let's say we will be making a cave with 12 cells. Then what we do, we select a cell, preferably in the middle of available space, and then we randomly select direction. So let's say we selected right direction. What we do when we uncover cell, we decrease this number. So at this moment we have already 2 cells uncovered, so this number would not be 12 anymore, it would be 10. But then we select another random direction, and let's say we selected left, and that is completely fine. It can go back already on the already uncovered cells, but then we don't decrease the number. So if it went here, it's still 10, it went here, it's 9, it's 8, it's still 8, it's 7, 6, 5, 4, 3, back, 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 2, 1, and 0. And here, if we would remove the borders, we would be left with this space over here, and that would be our cave. I know for this small grid it doesn't look that effective, but trust me, for larger spaces it really looks great. So let's have a look at how we would implement that. Okay, so here, as I said before, I have my simple setup with the direction enum and the grid which we created in the previous tutorial. Now we'll have to add a little bit of extra stuff to make our life a little bit easier. So the first thing over here is when we have our grid, we have one way of creating an instance of it. So basically this constructor that accepts just width and height. Would be good to have another constructor which automatically allows us to initialize the values in the grid. Because obviously now if we create an instance of this grid, for example with an object of some type, those values will be defaulted to null. And this is not always what we want. We would have to loop through all the cells and so on, populate them. And why do that separately when we can do that at the moment of creating grid? So in order to do that, we create a constructor, public grid. Sorry, what is happening? Yes, public grid. It accepts width and height. Then what it does, it calls the constructor that we have above. So that this way basically it calls the previous constructor, but now we want to add one extra parameter. Now we can do that two ways. We either can create a func, let's call it init, that accepts three parameters: int, and returns. Sorry, did I say that it accepts three parameters? It accepts two parameters and returns t. It returns t because when you basically use funcs, the first types that you provide here are the parameters. The last one is the return type. Now, as you see, this is not really readable. I'm sure you don't really know what is happening here. This might be because the delegates in general are a little bit confusing. But even if somebody knows what delegates are, this kind of way of writing it does not tell us too many information. Basically what it means is that when we construct a grid, we want to provide width, height, and a method or a function that has two parameters that are ints and return the t type. We can make it a little bit more readable by creating our own delegate. So we do that by saying, for example, public. We want it to be available outside this class, so we make it public. Then we use the word delegate, which indicates that this will not be a regular field or variable, that we define the delegate type. Now we name it. So let's call it, for example, init function. And now what we have to do, we have to specify the return type. In our case, that's t. And we wanted to have two parameters, int for x and int for y, because at different places we may want to initialize the object slightly differently. We will actually, I ate an function. We'll do that in a second, so you will exactly see what is happening. If it's not clear yet what this means, what is happening, this will become clear when we actually pass this function. You will see what is happening there. Now, instead of using this, those two are equivalent to each other, so we can just replace this with this. Fantastic. Now what we want to do, we want to run two loops. So we basically want to go through the whole grid and populate each cell. So for that, we need first loop which will go in x direction. So here it has to be smaller with x++. Awesome. Then for var y equals 0, y smaller than height, y++. This basically goes through each cell in the grid. And now what we want to do for each cell, we want to set at x and y. So at those two particular coordinates, we want to call init with x and y. So basically what will happen, this function that we will pass here returns us the thing that will be in the grid, right? So this will basically run this function, this will return the thing, and we will put it at the coordinates x and y. So that is first thing that we needed to do. Now we will create simple type for the grid cells. That is because we will want the cells to be aware of their coordinates. Normally, for example, in this grid, we can put whatever we want. So if we put, for example, booleans, because that is what we will be working with, each cell will not know at which coordinates is, which would be pretty difficult to work with. So what we can do, we can just create a new class. Let's call it GridCell. Yes, let's add it to Git. Fantastic. And now we want it to have three properties. First one will be public int x. We want it to be available from outside. Then y. Then we want there to be a value. Whoops. And the value can be of different types, right? Because today we'll be working with booleans, so it will be for boolean, but in general it could be whatever we want. So let's make the grid cell generic, and now let's make this field generic too. So this will give us a lot of breathing space. Now let's call the field the property value. Create a getter and setter for them, and now the only thing that is left is a constructor. So public grid cell, we want x, we want y, and we want the initial value. The value. And now what we do, we assign x to x, y to y, and value to value. Beautiful. So now we have something that will be slightly easier to work with. Okay, so now it is time to create our cave. So I'm adding new class and call it cave. Yes, let's add it to the Git. And now I need a constructor. So this constructor will accept width and height, maximum width and height of the cave, because we would be possible, but in general we in the simplest form we don't kind of specify the minimum size of the cave. We can specify just the maximum space, and that is basically the size of the grid that we'll use. So here we do int max width, and then int max height. Awesome. And we can initialize and create fields for those ones. Awesome. So we have those two fields. And now obviously we need to populate our grid with default values. So for that we create another field. This time of type grid. And the grid of grid cells of type bool. And let's call the variable grid. Awesome. Now we need to import the references. Awesome. So we have the grid. Now we have to populate it. As you remember, we created this constructor, which allows us to provide initialize function. So the thing that should happen, or maybe the specification of how the item in the grid should be created. So for that, we'll create a simple method. So over here, we create a method which will be called private. It has to return the item that we put in the grid, right? So grid cell of boolean, and let's call it initialize cave cell. Awesome. And we need to know at which coordinates we want to do that, because if you remember, again, our init function requires two parameters, x and y. So as you see now, our grid is of type GridCell of Boolean. So that is what the type T will be. So that means now we have method which kind of perfectly matches this this delegate. So it returns T, in our case GridCell, and it accepts two parameters of type integer. The names do not have to match. The important thing is that the types match. So we have this method. What we do here, we simply return new GridCell with coordinates x, y, and the default value true. Because basically, by default, we want all the walls to be built, and then we will be removing or like digging the corridors inside the walls. So we have that, and this allows us to do some magic. So now we will initialize our grid, and in order to do that, we simply use the constructor we had. So here we use the max width, max height, and then what we do now, we just pass the name of the method which matches the delegate. And what will happen then is basically when the grid is constructed, this loop will start, and for each x and y, this method that we provided will be called with those two parameters that we provide here. So x will be from here, y will be from here, and the grid cell will be constructed. So that will be the base. Now let's create a class which will allow us to finally display it in the Unity editor. So I'm creating a new class and call it CaveGenerator. This class has to extend monoBehavior because this will be the one class that will be attaching to a game object. Let me zoom it a little bit. And now what we want to add some serialized variables to store some important information. So the first one will be of type tilemap. It will be a tilemap that will store our walls. Then we want another one that will store our ground. Now, obviously we could have just one tile for ground, we could have just one tile for wall, but this will create very repetitive, very boring cave. So we're going to use arrays of tile base. So serialize field, private, and tile base, that is the type of one particular tile. So when you want to drag and drop tile, the type is not tile but tile base. So we do that, we call it wall tiles, and another one ground tiles. Now, because our cave has to have defined size, we create another two variables to store the maximum width and maximum height of the cave. So int max width, serialize, private int max height. Awesome. And later on we'll need some more variables, but let's worry about them then. And now we're going to create a method that will generate our caves. So let's call it public void generate cave, or actually, because the class is already called CaveGenerator, we kind of assume that it will generate caves. So to do not repeat the type, it will be simply generate. Now let's add an attribute context menu, and let's provide the parameter, the name of the method, generate cave. Now, if you don't know what this attribute does, basically, if you go to the Unity editor, here we have the grid. Let me drag and drop the script over here. If I click now right, you see I have this option here, generate cave. Whenever I click it, what will happen? This method will be called. So if I will add here debug log hello from generate cave, I can open a console and call the generate cave method, and you see everything there executed. So what we want to do there, we want to create our cave. So cave, new cave, and now of max width and max height. Awesome. It has a grid, right? So inside this cave we have a grid variable, which at this moment is private. So let's expose it. Public GridCell of bool. Now let's call it grid with capital letter, and let's return grid. Now I will use the magic of my IDE to actually combine those two variables to auto property. Poof, magic. So those two, so this one and the previous one, are equivalent. So we can have just one doing that. And that means that, again, the thing from the grid tutorial, that means that we'll be able to assign this variable from the constructor, but then we won't be able to modify it. And this is actually what we want. So we can go back to the cave generator, and now we need to kind of draw the cave on the tilemap. So for that, the first thing we want to do, we want to clear both tilemaps. So wall tiles, no, sorry, walls tilemap, clear all tiles, ground tilemap, clear all tiles. This will ensure that when we call the method, both of those tilemaps will be cleared. So for example, I can actually do that. So for example, here I have generated cave. Now if I call you generate cave, whoops, of course I haven't assigned the variables. So this is actually a good moment to do that. I open the grid object, and here I have created two simple tilemaps. They are just default tilemaps. The ground tilemap has a different color to be a little bit darker, but that is really all. If you don't know how to create tilemap, you simply click with the right mouse button, go to the object, and then tilemap rectangular, and that's all. So here I have the tilemap, sorry, here I have the grid, and that will be my walls tilemap, and that will be my ground tilemap. Awesome. If I call the method now, poof, everything cleared as expected. Awesome. So now let's populate the tilemaps. For that, we can loop through each cell of the cave grid cells. Now, because our cells are aware of their coordinates, it will be pretty easy to set details at the right coordinates. So first, we can check if the cell is, if the value of the cell, because our, just to refresh, our grid cell has a value now of type boolean, because we provided that over here, right? So in the grid cell of bools. So we can simply check what CaveGenerator over here. So we can check if the value is true, and that means the wall should be there. So what we do, simply set on the wall's tilemap detail at new vector3 int at given x, so cell x, cell y, and 0. Sorry. One of the tiles from the wall tiles. So let me just pick up random from the array. So we can do that multiple ways, but let's do that the simplest way. Var random wall equals wall tiles, and now random range int should be there. Just give me a second. Which range. Okay, so if I provide the integers, it will give me back integer. Awesome. So from 0 to wall tiles length. Basically, the last value is omitted, so it's including the first value, but the second one is excluded. So it will be value between 0 and the wall tiles length -1. And that will give us random tile, which we can use over here. If the value is false, however, we want a random ground. So we do that here, and we can use ground tiles. Let's paste it here, and let's call it random ground. And again, we can just copy, paste this one. This actually already we see would be pretty easy to extract to a separate method, because it differs only by different parameters in different places, but let's just for saving some time keep it that way over here. So here we need to also change that, and that should be it. Yes, so this should in theory allow us to populate a tile map with the walls, with random walls. So now we need to create the tiles. I already done that, but let me just show you how you do that. So basically, when you click here on the tile map, you have this 9 dots here. You press on this one, and you will have no palette selected. So I have walls because that's what I created. You can click simply create a new palette, save it, and then what you will have to do is basically drag and drop the sprites of different tiles, right? So I have here, as you see, 1, 2, 3, 4, 5 different tiles. You can drag and drop them here, and they basically will become the tiles, and you will be able to use them. Important thing, when you draw them, sometimes you may see, let me just show you the grid over here. So you see it is a little bit going a little bit over the grid. That's how I set it up, because I prefer I don't want any empty spaces between the tiles, and my tiles are not in perfect shape, so it's a little bit better if they go over the edges. In case your tiles are too small, what you can do, when you click on the sprite over here, you have this pixels per unit setting. If you change this value, so for example, if I change it to 50 and apply, you see the tiles became bigger. If I increase it, so let's make it 100, you see it became smaller. So for my tiles, the 72 pixels is the perfect size. So now, every time you create a new tile, you will have to save it. So I have it saved here. And in my script, I can add, I have 2 walls. So those bricks over here, I just drag and drop them. And then ground tiles, I have 3 of them. And you see mine are pretty boring. But if you, for example, have a cave where, I don't know, the humidity is very high or something, you could have a moss, or if it's very cold, you could have, I don't know, ice and things like that. So, you know, this way you will create more variant, or like more different variants of caves. And this is really amazing, and it really is more interesting for a player to look at. So now, I don't have to remove those ones, because that's what my script will do at the very beginning. Let's just set the size of the cave to 10 by 15, and let's call the generate cave method. And now, if I remove the gizmo, you see it looks quite interesting, because it's not as repetitive as it would be if I would have just one tile. So this is pretty amazing. Okay, so it is finally time to implement our walker. We'll need one kind of helper method, which will give us a random value of an enum. So let's create a class, let's call it randomUtils. let's make it static, and let's create a static method, public static t get random enum value. And I'm not sure you are aware, but methods also can be generic. So usually we think that only classes can be generic, but it's not true. Methods also can be generic, which is pretty convenient. If you would like to learn more about generics, I will link the tutorial somewhere there. Awesome. Now we need to put a constraint because we have to be sure that we always provide an enum, right? So where t is of type enum. Awesome. And now the rest is pretty simple. So what we need to do, we need to get all values of a given enum. So enum get values, and now we can kind of get the type of the enum from the generic type. So we use type of t. Here in this array we'll have all the values of the given enum, and now we simply return values get value, and now we have to provide the index, and for that we just use random range 0 to values length. And of course, because this method is not generic, so we don't provide type here, right? So we don't do something like that, and what it means is basically returning as a values as objects. So this is array of objects, not array of a specific type of a given enum. So this fails because we try to return t, which is of specific type, and here we try to return object, and .NET doesn't know what to do with it, so we have to help it a little bit and just cast it explicitly to the t type, and that will give us the random enum value. Now let's implement finally the worker. I promise you that this is now. Okay, so let's open the Cave class and let's create a small helper method. Just kidding. Okay, so now we create a private method. Let's make it return nothing for now, and let's call it DigCorridors. As you remember from the explanation of the algorithm, we have to specify the number of cells we want to remove. So let's create a parameter for that of type int cells to remove. Awesome. The first thing we have to do now is to find the place of the central, or the coordinates of the central cell, and in order to do that we simply let me just call it worker position. We simply divide the width and height of the grid by 2. So we create a new vector to int, and now for position x we use the max width by 2 and max height by 2. It might seem a little bit strange because we have vector to int, which expects us to provide integers, but this clearly can be a floating point number, right? Because if this is 15 and we divide it by 2, we will get 7.5, right? No, because if we divide integer by integer, what happens? Basically, we discard everything after dot. So if this is 7, if the result would be 7.5, what will happen? The result will be 7. I know it's a little bit unintuitive and it caused people to really get crazy, but now we have the worker position. What we can do now, we can create a while loop, and when we still have cells to remove, so when the cells to remove are at least larger than 0, we remove the cells, right? But how we do that? So first we decide which direction we go, so we need to select random direction. As you probably remember from the previous tutorial, we have the direction enum, which has those 4 cardinal directions, and then this convenient method toCoords, which converts it to a movement vector. This, by the way, could be vector to int dot up and this type of stuff, but we've done that way recently. Okay, so let's just create Cave go to cave class, and now first var random direction. So random utils get random enum value, and here we provide the direction. So we provide our enum. That's how it works. That's what this, you see, this generic method allows us to do. So because this method is generic, what will happen, the return type will be of type direction, so no casting, no anything like that. Pretty convenient. Now we can check the new position of the walker, right? So new walker position, and now let's make it the new old walker position plus the random direction, 2 chords. Boom. And this is our new position of the walker. Now we have to check if the position is valid, because obviously it could be outside the grid. If now our grid, our coordinates valid, new walker position, and now there is the second parameter which indicates if we want to protect the walls or not. So again, from the intro, if you provide here false, the borders can be removed. If you provide here true, the walls will be unbreakable. So I don't want to break the walls. So that is if the coordinates are valid. But let's reverse it. So if the coordinates are not valid, then simply continue. So start the loop from the beginning and select new direction, which hopefully will be valid. Now, if it is valid, and if the grid get now position at the new walker position value, so if we have a wall right at that position, what we do, we remove the wall. So grid get new walker position value equals false, but now we see we have that twice, so we can just grab and store it in the variable. So cell value, and also here cell value. And what we have to do when we break the walls or dig the corridor, we have to also decrease this variable. Awesome. And now if we got here, no matter if we broke the wall or not, we have to set the walker position to the new walker position, because obviously it made a step, and now after all the actions it is in the new position. And if I didn't break anything, this should be enough. This method is private. Let's make it public. Let's copy it, and let's just move to the CaveGenerator. And for now, let's first create a serialized variable for the number of cells to remove. So private int cells to remove. And now what we do cave and DigCorridors with the cells to remove. And that should be it. So let's try it out. So let's make it maybe better size, so 1510, and with 0 it should work too, so nothing should be removed. Awesome. If we put here 10, we have small cave. If we put here 25, and we have caves. Awesome. So you see, as I probably didn't mention it, but the benefit of this algorithm is because it works like literally manually, step by step. It has to visit all the cells. You see that each place in this cave is always accessible. So there is no situation when we create a room which is not available for the player. And I think this is great for different types of games. So it's awesome, especially if in your game the player cannot break walls. So you are 100% sure you will have you don't have to worry about that. Okay, let's do one last thing. So as you see on this grid, I have quite a lot of cells which don't do anything. They literally don't bring any extra value to the game or anything like that. They simply occupy space. So it would be good to have a method which will allow us to kind of shrink the grid to the size of the case plus borders. So let's implement that now. In the cave class, let's create a public method called shrink. And now, first thing we need to do, we need to get the cells which are not occupied with walls, because we want to find the kind of coordinates of the edges. So for that, we can create a variable, let's call it empty cells. And now let's use link to get them. So let me think. Grid cells where, in case you don't know what where does, let me just maybe finish it first and I will explain it. Yes, so here I have array of cells. Now I'm using the where method, the link method, and basically what it will do, it will evaluate each element in the array, and if this expression equals true, then this element will be returned together with all others that for which this expression is true to new enumerable. So this is a pretty convenient, a pretty short way to get all elements that kind of to filter certain elements out. This is here, and now because it returns enumerable and we will want to do some extra stuff with it or some extra link methods, let's just convert it to array so it doesn't complain that there are possible multiple enumerations. This is a little bit beyond the scope of this tutorial, so yeah, don't worry if you don't know what it means. Sooner or later I will make a video about link and I will explain it there in details. But now we have all cells which are empty, and now let's find those 4 coordinates. For min x, we do empty cells, min, that's another link method, and let's just say we want a cell with the minimal x. Now we want the same for max x, empty cells max c x, awesome. And now we want to calculate the shrunk width. So shrunk width max x minus min x plus 3, because we want the borders. And I know you think there should be plus 2. I was thinking that too, but when preparing for this episode I realized there is plus 3. Arrays are 0 based, right? So the indexing starts from 0. This would give us, so this gives us like one smaller result than we would like to. So that gives us plus 1, plus we want to add the borders as well. That's plus 2, so together it's plus 3. Now we need to do exactly the same thing for height. So min y, max y, and over here we want to check the y coordinates. Over here we want to call this one a shrunk height and do that. Awesome. So now we have the size of the grid we want. So now let's create a new grid, and now let's again build all the walls. So let's create it, grid of type grid cells bool, and let's make it of the size we know now. So shrunk width, shrunk height, and you remember we created a method which we provided, right? So we can just simply use it and give it here. Just to let you know, small tip, in case you don't want to create a method, you can also make a inline function here. So you can do x, y, and then you see new grid cell at x, y, and true. This is a little bit more cryptic, so I found this to be a little bit easier. Those two forms of doing that are equivalent, but you know, this seems a little bit less readable if you don't know what is going on there. So I will just stick to the name of the method. So this means we have now small grid with those coordinates. So now what we need to do, we need to iterate for the cells, but not starting over here, but over here, right? So at the cells which we want to copy. So as we remember here, we have the x of this cell, so we know we want to use this one minus 1. So we use for var x equals min x minus 1. Awesome. And then we want to continue until the x is smaller or equal the max x. Then we increase the x. Awesome. And we need to do the same thing for y. Now this will be a little bit complicated because our two grids have different coordinates, right? So basically where this has when the main grid has min x minus 1, right? So this could be 7. This grid has 0. So we have to somehow translate the coordinates between each other. So let's maybe split the reassignment to 2 steps. So first we get the value from the old grid. And this is pretty easy, right? Because we know the value will be simply grid get and x and y. So nothing crazy here. We can actually then assign the actual value here. And now we need to find the new cell. For that we do new grid and now get, and for that we do x minus min x plus 1, and the same for y. So y minus min y plus 1, and that gives us the cell, and now we assign to its value the old value, so what we got here. And this should be it. So now we go to the CaveGenerator, and under the DigCorridors we simply call shrink method. Whoops, yes, shrink. And this should be it. So let me clear the console to see if we have any errors. And now let me call the method. And it doesn't work. Why? Of course it doesn't work. Because in the CaveGenerator, in the cave, we forgot to assign the new cave to the old cave. So we need to replace the grids, obviously. So the grid should become new grid. And this will throw us an error because the grid is read-only. So we need to make it also settable from inside the class. And now everything is all right. Let's test it out once again. Whee! And everything works the way we expected. And now the last small thing, just rather as a tip. You see, I really hate doing that. So I have variable cave here, then cave do something, cave do something. If we have a method that modify kind of the internals of a object, I like to be able to chain them. This is pattern called fluid builder. So instead of, because we basically build a cave step by step, right? So we say, okay, here I have a cave which is of certain dimensions, and now dig corridors, that many in this cave, and then shrink it, and then blah 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 blah. So in order to be able to chain that, you will see in a second what I mean by chain. I can go back to the cave, and instead of returning void, I can simply return the cave. So yes, the cave will be returning cave. Now, obviously I'm getting an error here because I'm not returning anything. So just before the method finishes, I'm going to return this. So I'm returning exactly the instance of the class that is executing this method. So it's literally like return self or something like that. And the same thing over here for shrink, and at the end return this. We go to CaveGenerator, and instead of doing that, we can do now this beautiful thing, new cave, and now enter, DigCorridors, cells to remove, enter, dot, shrink, and look how beautiful it is. Okay, so that will conclude the tutorial. Hopefully everything still works. Yes, it works. And Awesome! Have a fantastic day, love you, and bye bye.